Yeah, first spoiler, I'm not crazy. I'm not crazy, okay? There is a reason why I'm wearing this suit. So, my name is Dario. I'm from, try to guess the location, you know? Coming from Italy. And the reason why I'm wearing this suit is because I'm not a Ghostbuster, but I am a ClusterBuster. So, you know, Ghostbusters are busting ghosts, and instead of classics, we are busting Kubernetes clusters. How? Using multi-tenancy, but I'm going to talk about multi-tenancy, but it's a long story. Anyway, parental advisory, dank memes on their way, because I do a lot of jokes, as you can see here, no, you can get it, but yeah. So with that said, since we got just 30 minutes, so what is Kubernetes multi-cluster management? But that's the wrong question, because we have to ask ourselves, why we have to do multi-cluster management? And there are plenty of reasons for that. I'm giving for granted that you know what is Kubernetes, and are you using Kubernetes in production? Raise your hand. 50%, something like that. I'm sorry for you. For those who are using Kubernetes clusters, I mean, don't worry. Anyway, you're adopting multi-cluster management because essentially you need to create multiple clusters for various reasons. The first one, you want to avoid the single point of failure about your application. So you need a different site, a different data center to host your own applications. And there are plenty of them, but keep in mind that I want to focus, since we are here talking about site reliability engineering, about the blast radius. So, you know, blast radius. So essentially, you want to say, I don't want to get my application to be to get considered down, so I'm gonna replicate all the applications across multiple clusters. But obviously, there are some pros and cons. And the cons of having multiple clusters, it means that in the end, you got a lot of reliability, but you got a lot of operational burden. So you have to take your own choice. Going for a huge cluster, that's great because we are saving a lot of resources, but that's really bad because obviously if it fails, we are fired. And with that said also, since we were talking about multi-tenancy, this is a meme because I do, my main job is doing memes. So, okay, I'm not doing open source, I'm doing memes. And this is what happens every time you're a site reliability engineer and the dev team say, we want to get our own cluster, so please create one. And obviously you are the one on call, and that's what's gonna happen. So multi-cluster is used to decrease the blast radius of your applications, although introducing a lot of toil. And obviously there is a huge rise of platform engineering, so each tenant or each project, each organization in your own company, they are demanding for a Kubernetes cluster. So let's try to step back and say, how can we achieve multi-cluster? But that's the wrong question, because we have to understand the tools and the best practices. Obviously, my own 2 cents. So far, I learned that the cluster must be treated as cattle and not like pets, like virtual machines. You know, we did that with from virtual machines to containers, and the same way must be done also for Kubernetes clusters. And the right tool to address multi-cluster management is Cluster API. So for those who don't know Cluster API, essentially it's a operator running in a Kubernetes cluster that is creating multiple Kubernetes clusters. And you're saying, oh my, it's unbelievable. But yeah, we are so crazy, we are doing that kind of stuff. So essentially, keep in mind that Kubernetes is really good because you got a lot of machinery, you got a lot of events, and essentially, it can be your own single pane of glass in regards to multiple clusters. So you can create on AWS, on Azure, on vSphere, on whatever you want, okay? And obviously, another buzzword besides Cluster API, Kubernetes, and so on and so forth, we got GitOps, okay? So essentially, we are not asking to create a cluster, but we declare the fact that we want a cluster. And that's really good because in the end, we can get a lot of benefits from that because it's reproducible, and also you create a sort of chain in regards of the review, creating more clusters and so on and so forth. So with that said, you can say, I'm Brandon Rambo. Okay, everything is fine, but the reality is way more complicated. And welcome to my session where I explain how I had a burnout as a site reliability engineer. So we are talking about site reliability engineering, a case study. So from my personal experience, I've been a software engineer, then I turned DevOps, because I was following the hype regarding buzzwords on LinkedIn, and I started doing site-reliability engineering. And meanwhile, I was also doing some cluster management. So I was working as a site-reliability engineering, and we were running everything on-prem, so you can understand why I lost my hair. But we were just running 5 production clusters, so that's pretty small, not a sizable amount of clusters. But each production cluster was, on average, 500 nodes with 40,000 of applications, so pods, services, and blah, blah, blah. No follow the sound, so I'm sorry for PagerDuty there, but I really know the robot voice calling in the middle of night, and we were just 8 people, I'm sorry for that. And Murphy's Law, because if something can go wrong, it's gonna get wrong. So, another meme, so that's me, a Dune reference. I don't know if you know Dune, there is the new movie, yeah, Shia LaBeouf. So anyway, that's my experience so far in managing Kubernetes clusters. So it's really painful. So managing a Kubernetes cluster is totally overwhelming. So it's not so easy as people are saying at KubeCon, yeah, Kubernetes is easy. No, it's not easy at all. So I'm just sharing my personal experience. We can talk about that and sharing also your pain. But keep in mind that essentially you have to do a lot of stuff. And you have to mostly take care of etcd, my nightmare, okay? Because etcd is the key value store where all the data of a Kubernetes cluster is stored. So it's the source of truth, and it's based on the Raft algorithm, so it means that you need at least 3 replicas to support a failure, and if you increase also the amount of replicas, you're getting with huge troubles in regards to performances, but keep in mind that if you're lucky enough, you can use a managed Kubernetes service, so you're paying AWS. I'm sorry for the mention about the vendors, but you're getting the point. So you use the hyperscalers, so you're paying something like $75 per month on AWS for the EKS cluster, and you can have good sleep. But obviously, it happens that sometimes we are not so much lucky, so we need to be our internal AWS for our own organization. So trying to recap everything. So the cluster are scaling, but people don't, because we are living in a shortage. We are living in a shortage period about shortage time, about resources, and especially also about people, because people don't want anymore to do Kubernetes, and they are doing great, because obviously I wouldn't go for Kubernetes if I could. But Kubernetes at the same time is not effortless. Obviously, we got a cluster API that is helping a lot, but the real problem is the fact that we are ending up with the control plane. And control plane means that we have to deal with etcd, doing the certificate management, and so on and so forth. So in the end, too long didn't read, everybody want to use Kubernetes, but nobody want to manage it. So with that said, I try to find a solution, because I'm pretty mad wearing also this GhostBuster suit. But with great power comes great responsibility. So with that said, I decided to start a journey, and it's the Kube Inception. So yeah, people started looking at me like a crazy guy for some reason, but not just for the Ghostbuster costume. But talking about Kubernetes, Kubernetes are pretty popular right now. It's the new black, and operators are a thing. So essentially, operators are a way to manage complex stuff in the Kubernetes native way. So you can imagine databases running on Kubernetes, but if you're using OpenShift, anybody use OpenShift here? Oh, somebody is using OpenShift. So OpenShift is full field of operators, and they are really great, because in the end, you don't need to do the dull stuff. Essentially, there is someone, a binary, that is running inside of Kubernetes and is doing the hard job for you. And at the same time, I thought that in the end, if you think about Kubernetes, it's just an application. So an application is a front-end HTTP. We got a database, and we just need to manage this application like regular ones, because everybody is running on Kubernetes stateful data, because we got the front-end API, we got the back-end API, databases, and so on and so forth. And also, I want to push more on the fact that we need to be reactive. I don't remember the name because too many things at the same time, but there is the reactive manifesto in regards to infrastructure. So essentially, what you have to do is to react to events rather than working as OpenStack based on messages. So it must be totally declarative, and also at the same time working based on events. So I got an outage. I got the API server that is throttling. I have to do something. So input, output, like input, output for machines. And this is the reaction every time I try to say, why cannot we run Kubernetes as a regular Kubernetes application? So running as pods. And people is getting crazy about that. And that's the reason why I also decided to get the title for my presentation, Will Real Kubernetes Multi-Cluster Management Please Stand Up, because I was really in depth with Eminem. But by the way, if you think about that, Kubernetes is already running, I mean the control plane running as pods, because they are running as static pods. So it means that we got the virtual machines, pre-virtual machines, at least if you're facing production, and in varlib manifest, I don't remember the exact path, but you can see the manifest of the pods. So it's already running as pods. So what's wrong with that? And I'm presenting you Kamaji. Okay, there is another reference here about Kamaji. We can talk about that later. Spirited Away, Studio Ghibli. Anyway, because I'm really a huge fan of that. I'm a nerd, I think that you can understand that. And Kamaji is an open source project that essentially is running control plane as pods. So we got a sort of management cluster where these control planes are created. And from there, we can offload the entire day 2 activities to the operator. So I want to create a cluster. I just define my specification, and then the operator is creating the certificates, the CA, the config map for the configuration, for the kubeadm add-ons, and blah, blah, blah. And what's the benefit of that? We are going to talk about that. But they're safe because they are running as containers. Well, safe as containers, and they are cheap because we are not running virtual machines. Virtual machines are really expensive. And please don't forget to leave a star on GitHub so we can donate the project to the CNCF. Shameless self-promotion for that. Sorry for that. Anyway, I'll try to summarize how it works. We got this management cluster that is the admin cluster, and essentially we are not sharing the underlying infrastructure of the management cluster. Okay, because otherwise you're getting some troubles in regards to the scaling abilities of Kubernetes. Kubernetes cannot scale out up to, cannot exceed 5,000 nodes. And I don't remember, there are links on the slides about consideration for larger clusters. But the benefit of Kamaji is essentially that you can bring your own nodes. So it's like EKS or AKS. You bring your own nodes, so you are paying for that. And essentially, the control plane is in a management cluster, and you're consuming that as a service. We are consuming right now DNS as a service, okay? We are not managing that. So essentially, it's the same stuff. And we are running as pods. So we can reuse the machinery and the event loop offered by Kubernetes to be reactive and also to perform auto-scaling, so a lot of stuff. Another slide of shameless promotion about Kamaji, and is the fact that it was born from my personal experience in managing Kubernetes at scale. So I try to say, Dario, if you could get in the past what you would like to get from an open source project to reduce your toil, it should be this, and I started implementing that. And obviously, keep in mind that I forgot to mention that obviously, if you can see here, I'm not referencing an etcd. So what we did is to take full advantage of the multi-tenancy from the infrastructure layer to the data store layer, to the application level. So it means that we are not managing one etcd per tenant control plane, but rather we are using one or more data stores per multiple control plane. So with that said, it means that you can pick your own strategy. Let's imagine I work in a bank. I got a different branches, and each branch has multiple departments. So what I can do is to create a data store for that branch, and on that data store, I store all the data, all the etcd or MySQL or PostgreSQL data, and that I have as my customers. And with that said, as I said before, we are not using the underlying infrastructure, but we are consuming Kubernetes as a service like EKS and AKS. So it means that the competence, the center of cost are my nodes. So I can bring my nodes from any infrastructure provider, even on different cloud providers. When we do the demo on the meetups, we are explaining, the control plane is on Azure, and then we got the worker nodes on a different cloud provider like Amazon Web Services, and it works, okay? I cannot show you in the demo, but trust me, okay? Trust the crazy guy here. And also, with Kubernetes, essentially, we are taking full advantage of the machinery. So everything is done by the operator. So if the API server dies, a new pod is going to be spin up. If I need to scale because I got the API server that is churning, I can attach a horizontal or vertical pod autoscaler, and I can solve that. So essentially, it's like democratizing the managed Kubernetes service experience. So you can use Kamaji, offering a lot of clusters. So this is what I said before. We are using multi-tenancy to achieve that. And the benefit of that is that we are ending up with a single pane of glass. So you are not going crazy saying, oh, I got multiple clusters, but where are they located? So I need to understand, download the kube config, and blah, blah, blah. Everything is done by Kamaji. And obviously, since we talk also about Cluster API, we are working with the Cluster API project. Keep in mind that it is a Kubernetes 6 project, and you can join the discussion. Right now, we are having some issues because Cluster API is based on the provider concept. So it means that if you want to create a cluster on AWS, you have to use the Cluster API primitives, but also the API definitions by AWS. And unfortunately, I'm not talking about AWS, but there is a highly coupling between the worker nodes and the control plane. We are working with the community to try to address that, and I'm feeling really positive about that. But obviously, everything seems pretty shiny, you know. It looks like, oh, with Kamaji I can solve all my problems, but obviously there are some downsides, or doesn't, who knows. We can talk about that. Mostly, I can say, if I would be a bad actor saying, etcd doesn't scale. Or what you can do is to say, etcd managing a Kubernetes cluster is really painful. You cannot do that. And please, Dario, stop, because you're using a single management cluster for multiple clusters. It's single point of failure. Or if you want, we can engage in discussion after the conference, after the talk, so you can share your own. So I got new material for the upcoming events I have to attend. So thank you so much. It's crowdfunding. So let's talk about etcd cannot scale. And that's true. End of the story. No, but you can avoid using etcd. If you heard me, I said PostgreSQL, MySQL, even SQLite, and the solution between inverted commas, it's Kine. Kine is not etcd, and essentially it's an etcd shim, a sort of adapter that is translating the gRPC calls that Kubernetes is doing against etcd and translate to a different driver. So what you can do is to say, I use SQLite, MySQL, or PostgreSQL. Use PostgreSQL, okay? Keep in mind that since we are talking about running at scale Kubernetes, I know it's a pretty extreme topic, but I love extreme stuff. We know that there are plenty of Kubernetes clusters on AWS, on EKS, on AKS, GKE, and so on and so forth. And keep in mind that most of them, I cannot say the name because otherwise they will sue me, they are not using etcd. Or rather, they're using etcd, but it's a fork, so it's pretty complicated. So the real pain point here in Kubernetes is etcd, and we can talk about that because it's really complicated. Anyway, don't use etcd, use Kine, use PostgreSQL. And also, in regards to etcd, since it's really challenging, what you can do is to use a different approach, because etcd doesn't have sharding, doesn't have partitioning, and doesn't provide also a native way to perform replication. So using Kine, what you can do is to say, we can use PostgreSQL. And I'm sponsoring this really cool project that is Cloud Native PG. And Cloud Native PG allows to run PostgreSQL on Kubernetes in the Cloud Native way. So what is Cloud Native, okay? What the fuck is Cloud Native? Where is the event? What the fuck? You already did that, I don't remember. Anyway, Cloud Native is a way to manage resources with a different approach. And the same applies also with PostgreSQL. So you're defining the instance, you define the migration, you define the geo-replication and the backup and restore, and you are not underlying it to the infrastructure, but you're managing at the application level. Yeah, it's a bit opinionated, but it's really good. So with that said, you're ending up with a Kubernetes native integration. It's GitOps ready because everything is YAML files. Obviously, you need to install also the operators, but yeah, it's part of the trade-off. And what you can do with PostgreSQL is that you can have a global distributed managed Kubernetes cluster. We are gonna talk about that. But with PostgreSQL, you can have an active passive setup. So if PostgreSQL is gonna die, you get all automatic, how to say that, leader election of the passive replica. And with Kine, it's really cool because I saw the internals. They're pretty simple, by the way. So there are no updates or deletes, just insert. So PostgreSQL can manage thousands or millions of inserts per second. So it's really easy. And the selection, so when I issue kubectl get namespaces, there is a select on PostgreSQL. And what we are ending up is to say we can have a single PostgreSQL instance using the multi-tenancy with multiple schemes. So each scheme is a cluster. So it's like Lord of the Rings, one ring to rule them all. Yeah, it's pretty similar. And in regards of the Kamaji single point of failure, yeah, it sounds like that. But if you think about that, also AWS is your single point of failure. So what you have to do is to say, I need a multi-cluster and multi-cloud provider solution. And honestly, I'm saying something that is really weird, but what happens if my service goes down? Is gonna someone die for that? We can wait for that. You know, it's just information. We are doing silly stuff in the end, okay? We are not saving lives, okay? But it's a different story. But what you can do is to embrace Kubernetes. So it means that what you can do is to design the management cluster in the right way. So we got a management cluster with topology, pod, spread constraints, full, I don't remember, the tolerations, and blah, blah, blah. So essentially, Kubernetes is offering already all the machinery, all the tools to provide applications that are running in a high availability and fault-tolerant state. But obviously, one single zone, a single region cannot be enough, okay? So what we had to do is to create multiple solutions in multiple regions. So this is the global managed service. Keep in mind, it's a work in progress. Don't try this at home. So what we are doing right now with some customers is that we develop an active passive management clusters. So we got an active cluster, maybe on your preferred cloud provider, and then a passive one. So using GitOps, we know that when we commit something, automatically everything is replicated. So in the active and in the passive. And so with that said, we are not using etcd because etcd got a lot of issues, especially in regards to scaling, because X sunt leones, okay? I'm from Italy, I can use Latin. So exceeding 8 GB of database size of etcd, it's really dangerous. You don't know what's gonna happen. So you can overcome that with PostgreSQL. And PostgreSQL is really great because using Cloud Native PG, essentially we got everything configured for both clusters, so you're using the toil. And with PostgreSQL, we can set two instances on the main cluster where we got active and passive. So maybe we got two zones. So the active and the passive, and we perform the switchover if one pod is gonna die because maybe the node is dead and so on and so forth. But obviously, what we can do is to say, in the management cluster, in the active cluster, we perform a sync, a sync replication. So you need the acknowledge from the other replica. So you're sure that if shift happens, so I cannot say the bad word, if shift happens, you're not losing any data. And then what happens if the site goes down? You can have the passive site where everything is already deployed and is getting replicated from the main site, because PostgreSQL allows to set up in a complex way, but you can do that. Otherwise, everybody will do that. So I will not be here explaining that, but you can have an async replication, a geo-replicated data between the PostgreSQLs, and final last words about BGP. Okay, so when the main site goes down, you can announce saying, I'm now the right one to announce. So essentially, you're getting a sort of downside. Yeah, there is a small window, obviously, where shift happen. But you can get everything replicated across your world and blah, blah, blah. So keep in mind, Don't do that at all, okay? We are still working on that, but that's just our idea. So, trying to summarize everything. I didn't say that Cluster API is bad. Absolutely, Cluster API is the right tool to manage that. The problem with Cluster API is the fact that this is another take. All the vendors are saying, don't worry, you can create as many clusters as you want because they are not going to manage the clusters on your behalf. So it means that you need to take care of etcd, the control plane, controller manager, scheduler, and blah, blah, blah. So we need to find a different way to optimize resources and to optimize also the operational effort. And keep in mind that what you can do is to say, I'm running on-prem. Sorry for you guys, ladies and gentlemen, but yeah. I wouldn't go anymore on premises managing clusters. But if you can, maybe you can use managed Kubernetes services. They're really cheap. They are working. There are plenty of solutions out there, so you don't need to manage all these mess, okay? And also, keep in mind that this is not something esoterical. I mean, virtual clusters are already a thing because there is a nice project by the Kubernetes 6 that is the nested cluster API provider, and essentially there is this management cluster, the control plane are deployed as pods, and there is a sort of syncer. So when you ask to create a pod, this pod is deployed in the management cluster. But obviously, that doesn't work because you can bring your own nodes. You cannot use a different CNI per cluster basis. You have to use the same core DNS or DNS service and blah, blah, blah. Or, in the end, you can use also meta-clusters. Meta-clusters is a solution that I discovered some vendors are doing. I cannot say the name because there is an NDA about that, but they are already doing that. So it's feasible, okay? So, and try to summarize also some final words about Kamaji. So we are adopting multi-tenancy, and we shift the multi-tenancy from the infrastructure to the application level with the data stores. So it's going to be more scalable because we can use the machinery offered by Kubernetes, so the pods, services, compute master, ingresses, and blah, blah, blah. And we can offload everything to PostgreSQL, where we can overcome some limitations of etcd. There are still some limitations about PostgreSQL and Kine. I'm working with the people from EnterpriseDB, that is the company that donated cloud native PG. But in the end, what you have to do as final takeaway is to embrace automation. So we don't need any more issuing kube spray, please do this stuff, or cluster API, create machine, blah, blah, blah. You just define a manifest, and that manifest is going to be applied on your behalf. And in the end, you can create a cluster in a matter of seconds. I'm not joking. With Kamaji, we are able to create a cluster in, try to guess, how many minutes? 16 seconds, okay? Because these are containers, these are not virtual machines. And with that said, I guess that I'm the time, so question and answer, and that's all, folks. Thank you so much.